So why do I need to know what a limiting reactant is? Well, you're going to need it to figure out the amount of products you can make at the end of a chemical reaction. And this will become important for figuring out the amount of carbon dioxide that a fuel gives off, for example, when we talk about the carbon cycle and greenhouse gases. Let's just go through the steps of solving these types of problems. There's lots of different questions I can ask you, and I'll go through each type. So, consider this reaction where we have 3 moles of ammonium nitrate reacting with 1 mole of sodium phosphate to make 1 mole of ammonium phosphate and 3 moles of sodium nitrate. Think of this as just like a recipe for your favorite food. We got the 2 ingredients and they give us the 2 products. So if I have 30 grams of this ingredient, ammonium nitrate, and 50 grams of a second ingredient called sodium phosphate, I need to know the limiting reactant so I can figure out the total number of products or meals I can make. So that's the first question we have to ask. Which one of these 2 ingredients or reactants is the limiting reactant? Here are the steps, and basically the goal here is to find the limiting reactant by using stoichiometry and calculating the amount of product that is made by each reactant. So we're trying to figure out what's the number of pizzas we get from each ingredient. In order to do that, we need a balanced chemical equation. In this video, I've balanced it for you, but you should fully expect to get at least one problem on the test where you have to balance it yourself. The second step is to use stoichiometry for each individual reactant to find the mass of product produced. And you'll want to use that diagram that we learned about last week. The reactant that produces the lesser amount of product is the limiting reactant. The reactant that produces a larger amount of product is the one that's in excess, the excess reactant. To find the amount of remaining excess reactant, we're going to subtract the amount of excess reactant used up in the reaction from the total that we had at the beginning. And I will now show you numerical examples for each one of those steps. Alright, I've set up 2 unit conversion charts here. We need to take each reactant and figure out how much product it gives us. Remember, the one that gives us the lesser amount is the limiting reactant. The one that gives us the larger amount, the excess reactant. Now, which product will you convert to? Which grams of product? It doesn't really matter. I'm going to pick this one because it's the first one. It'll work for both. So, here comes the stoichiometry part. I need to go from 30 grams of a reactant to grams of this product. So the first step is using the molar mass of the reactant and then the mole to mole ratio of the reactant to the product and then the molar mass of the product to finally get to grams. Then I will plug that into my calculator and get 18.6 grams of the product ammonium phosphate. Let's find out how much product I would get from 50 grams of sodium phosphate. Again, grams of sodium phosphate, going to change it to moles of sodium phosphate using the molar mass. Then I'm going to change it from sodium phosphate to ammonium phosphate, from reactant to product, using the mole to mole ratio. Then, with the moles of the product, I'm going to convert to grams of the product using the molar mass of the product. And when you plug that into your calculator, you get 54.4 grams of this product. Now, just a reminder, if you are super confused about the math that was just done here, you need to go back and review stoichiometry problems. Now, which one of these reactants gave us the lesser amount of product? That would be ammonium nitrate. So ammonium nitrate is the limiting reactant in this problem. Big warning. It is not always the reactant that has the least amount here that's going to be the limiting reactant. That will not always be true. Do not fall for that trap. You'll have to go through the entire stoichiometry problem. Alright, so cool, we answered our question, which of the two reactants is the limiting reactant? What's another kind of question I can ask you on the test? What is the mass of product that can be formed with the amount of reactants that we have? So, one product being ammonium phosphate, we just did that one. Using the limiting reactant, we know at the most we can make is 18.6 grams of ammonium phosphate. I can also ask you about the other product. How much sodium nitrate can we make with the limiting reactant that we have? Well, we'll set up another stoichiometry problem to answer that question. Alright, I got grams of limiting reactant. I want to convert it to moles of limiting reactant using the molar mass of this reactant. I'm going to convert the moles of ammonium nitrate, the reactant, to moles of the product using the mole to mole ratio from my balanced chemical equation. Now I have moles of sodium nitrate. I'm going to convert from moles back to grams using the molar mass of the product. You plug this into your calculator and you get 31.9 grams of this product, NaNO3. Okay, so I'll plug that in here. The final type of question I can ask you here is how much of the excess reactant is left over after the reaction? How many ingredients of or how many servings of the extra cheese do I have left over, just like in the pizza quiz? And it is another stoichiometry conversion. I'll start with my limiting reactant. If I use 30 grams of ammonium nitrate, I can convert to the amount of grams of sodium phosphate, the other reactant that I will use. So first I'll go from grams of substance A or reactant A to moles of reactant A. Then I will convert using my mole to mole ratio to go from the reactant A to reactant B. Then I will use the molar mass of this reactant B to find the amount of grams. You'll plug it into your calculator and get 20.5 grams of sodium phosphate. Now, is that the final answer? Is that how much I have left over? No. Don't get too excited because you got through the conversion chart. We actually want to know how much we're left over. 20.5 grams is how much we used. So if we want to find out what's left over, we take what we started with, 50 grams, and we subtract what we used, 20.5, and we get leftovers, 29.5 grams of sodium phosphate left over. So these 4 questions are the types that I can ask you on this test. So please feel free to ask me questions about how to solve limiting reactant problems, and don't be too afraid of them. It's just like when you were solving those recipe problems. Which ingredient do you have which ingredient is going to limit you on the amount of product you can make, the amount of pizza or sandwich that you can make? And don't fall for the trap of this being 30 grams doesn't mean that every single time the reactant with the smallest amount of grams will be the limiting reactant. That is not true. Alright, good luck.